Wednesdays, we wear pink on the 7th of October. SWBA students will be able to prove algebraic equations. Okay, we're going to talk about these things called proofs. Okay, so for proofs, we are going to go through a systematic way of showing that something is true. A systematic way of showing that something is true. When you guys are arguing or discussing something or trying to prove a point, can you guys just say what the final answer is? Can you guys just say the point you're making, but you can't explain it? Does that work very well? No, okay, you have to show someone your thought process and how you get there, right? Because you're trying to explain to them how to get to this conclusion, aren't you? Okay, so that's kind of what a proof is. We're going step by step. We're saying, hey, every step, here's where I'm going, here's my next step, and here's why. Here's my next step, and here's why. Here's my next step, and here's why. And now here's the end, and here's how I got there, okay? And so that way there's a set pattern you can follow at the end of it all, okay? A path for you, okay? And so we're going to learn some different properties of equality. We're going to review these actually from Algebra 1 to help us out, okay? We are going to Proof Town. Yes, Kenny.
You could definitely say your dog is dropping the ball.
Okay. The addition property of equality says that, hey, if I add the same thing to both sides of an equation, it's okay. So if A equals B, any numbers A and B, if A and B are the same thing, or the two sides of the equation are equal, I can add C to both sides of the equation, and it's okay. We use that when we solve equations, don't we? We'll add the same number to both sides of an equation. Right? Have you guys done that to solve before?
Does that say A plus C?
Yep, A plus C equals B plus C.
Okay, I thought you were trying to spell add C.
No. Good question. Okay? Yes. So have we used that to solve equations before?
Yes, sir.
Like maybe you have, I don't know, 5x minus 3 equals 7. What would you do there? You would add 3, but you have to do it to both sides, don't you?
Yes, sir.
That's the addition property of equality, saying, hey, if I add the same thing to both sides of the equation, it's okay. In this case, we're just calling that same thing C. Okay? The subtraction property of equality, same idea. If we have a true equation, A equals B, and I subtract the same thing from both sides of the equation, it's A-okay. Have we used that before? Okay, what about 5x plus 3 equals 7? What would you do there? You subtract 3 from both sides. The subtraction property of equality is what tells us it's okay to do that. Multiplication property of equality. If A equals B, we have a true equation. I can take A times C, and that's going to be the same thing as B times C. So if I have x divided by 5 equals 2, what would I do there? Multiply both sides by 5. The multiplication property of equality tells me I can do that. As long as I do it to both sides, we're good. Division property of equality, if A equals B, then A divided by C is the same thing as B divided by C. As long as C isn't 0. Because you can't divide by 0 because otherwise that breaks math. Okay, you can't divide by 0. It's impossible.
Why did you do it earlier?
I didn't.
You said 0 divided by 5 is 0.
That's different. So you're dividing by 5. Here, we'd be saying you can't divide by 0.
Anything divided by 0 is 0.
Nope. Anything divided by 0 is undefined because it breaks math. You can take 0 pizzas and put it into 5 and split it amongst 5 people. How much pizza does each person get? 0, and you're sad. Okay, so you can take 0 divided by 5, but you can't take 5 pizzas and put it into 0 groups. Because regardless, if it's just sitting there, it's still in one group. It's all together. Oh, let's put it in the trash. Well, it's in one group in the trash can now. It's still in one group.
Let's dissolve.
You can't put 5, then you have 0 pizzas.
Let's eat it.
So you can't take 5 pizzas and put it into 0 groups. You can't put things into 0 groups. So that means you can't divide by 0. That's what you're doing when you divide. You're putting it into groups. Okay? So dividing by 0 breaks math. Can't be done.
The first person thought when they found that out, they're like,
Okay, questions on that? We have more properties as well. The distributive property. If A times the quantity of B plus C, then A times quantity B plus C will equal A times B plus what? A times C. The distributive property tells us we distribute the outside of the parenthesis to multiply to everything inside, right? Have we used the distributive property before?
Yes.
Yes, we have. Substitution property. If A equals B, then A may be replaced by B in any expression or equation. I put replaced with a D. It can be replaced by B in any expression or equation. Have we done that before? Like we've gone through an equation and we said, okay.
How could you forget that? What about the doggos?
Okay.
Betrayed us.
So if I like before in chapter 1, we might have had an angle and we said the angle measure was, I don't know, making this up, 3x plus 4. We solve our equation, we get x to be 5. Well, I can take, since x equals 5, I can take this 5 and plug it in wherever I see x. Remember doing that? Awesome. Reflexive property. Reflexive property for any number A is equal to A. A value will always be the same as itself. Am I the same height as me?
Yes, sir.
Okay, is Kenny the same height as himself? Okay, is Chase the same height as himself? Okay. Is Kevin as good as basketball as himself? Yes. Okay, you name it. Okay? Symmetric property. If A equals B, then B equals A. You can flip it around. So let's say for grins and giggles, I am the same height as Ray. What would that mean? Okay?
Very short.
Okay, but what else does that mean? If I'm the same height as Ray, then Ray is the same height as me. It works both ways, right? That's what the symmetric property of equality says. You can flip around the equal sign, okay? If I am as good as basketball at Kevin, which isn't true, then Kevin is as good as basketball, is as good at basketball as I am. What?
The way you said that was like, if I'm as good at basketball at Kevin.
Excuse me, I meant at basketball
I
then.
know, but like,
Okay.
We all have
it broke my brain.
Yes.
You're not an English teacher.
Oof. Okay.
But it could be the
Transitive property. If A equals B and B equals C, then A equals C. If A equals B and B equals C, then A equals C. If I'm the same height as Ray, and Ray is the same height as Landon, then what do we know? I'm the same height as Landon. Okay, we can draw that conclusion. Is that kind of similar to our law of syllogism?
Yes.
We're kind of cut out the middleman. Sorry, Ray, we're cutting you out, okay? We're going straight from me to Landon now. Since we're both the same height as Ray, we're both the same height as the third person Ray, that means we're the same height as each other.
Wouldn't Ray be the second person though?
Okay? Sure.
I mean, technically.
Either, however you want to think about it. Okay? Questions on that? Okay. Of course. Okay, so we're going to use these properties of equality in a two-column proof. So there's lots of different ways to do proofs, okay? And we're going to focus just on one of them called a two-column proof, okay? It's a very organized method, which makes it a little bit more straightforward, a little bit easier for us to grasp than maybe a less organized method, okay? So it's a common format used to organize proof. We have two sides of the proof, hence two columns. A left column and a right column, a left side and a right side. The left column lists the statements or the steps that we're going to follow. Okay, so we're going to say, hey, here are the statements or steps we are following. The right side, we're going to list the reasons that justify each step.
What can be the reason?
What can be used? Oh, yes, so that's our question we're going to answer. So we're going to list the reasons that justify the steps. So on the left side, we're going to say, here's my step. On the right side, we're going to say, here's how I can do that. Here's my step. Here's why I can do that. Here's my step. Here's why I can do that. Okay? So it's like when you're making an argument or a discussion with somebody, you're trying to convince somebody of something. You're saying, hey, here's what I'm saying. Here's why. Here's my point. Here's why. Does that make sense? Is that a common thing we do?
Yeah.
Okay? So what can we use as reasons? We can use properties, like these properties of equality we've been talking about today so far. We can use definitions. Just like you might use look up a word in the dictionary to say, hey, this might help my argument. This word actually means this. Let's talk about that, okay? You can also use postulates. Like we had the segment addition postulate back in chapter 1 saying, hey, if you add two parts of the segment, you get the whole segment. You guys remember that?
Wait a minute.
No.
If you can't use the word if you can't use the word to define the word, how can you define definition?
Okay, theorems. You don't have to use the word definition to find the word definition. You use other words to find the word definition. It's a roundabout circle, but you had to start somewhere. Theorems. Theorems. A theorem is a theory that was proven true in math. A theorem is a theory that was proven true in math.
Theory is a theory that was proven true.
A theorem is a theory that was proven true in math.
Somehow I don't believe you.
Okay, well, it's true.
You can choose to be wrong.
I was gonna say, I'm like, yeah, you don't have to be right. Okay, you have the right to be wrong. Okay.
He's always right. He has the power of doggos.
Yes. Okay. So we're given something in this proof. We're given that 4x minus 1 equals 27. We're given this equation. I think the batteries are dead, buddy.
Yeah, it is.
Sorry, it's a big L. It's up there. You got to turn it though. Okay. We're given this equation 4x minus 1 equals 27, and we're trying to prove that x equals 7. Now, would we have known this equation if we weren't given it?
No.
No. So we're given it. So our first step is going to be starting with, hey, here's what we're given. So our first step will always be whatever we're given. And how do we know it? It was given to us. Okay? Then in our second step, we have 4x minus 28. Well, how did we go from step 1 to step 2? What did we do? You added 1 to both sides, right? So what tells us...
Addition property of equality.
Great. What tells us we can add 1 to both sides of the equation? Seth said it. It is the addition property of equality. Now let's say we don't want to write out the entire word saying addition property of equality. Okay? We can write down this. Okay? Now, I often am going to find ways to shorten what I say, to shorten what I write. Because I'm lazy. Okay? I don't want to take the time or the effort to write out the whole thing. So, I'm going to shorten it up. But here's the thing. I'm not just going to say addition. Because addition is ambiguous. It could mean multiple things. It could mean you're adding two things on the same side of an equation. It could mean that you're adding across an equation. We don't know. But this is specific while also being short and abbreviated. Okay? So we can abbreviate things. We have to be very careful how we abbreviate things so they're not confusing. If you want to write out the full thing, you can write out the full thing. Okay? So it is the addition property of equality. It says we can add 1 to both sides of the equation. Now what gets us from step 2 to step 3? What says we can go from 4x equals 28 to x equals 7? The division property of equality, because we divided both sides by 4. So we use the division property of equality, saying, hey, if I divide both sides of this equation by 4, I'm going to be A-okay. Now, do we notice that the work is missing of the adding 1 and the dividing by 4? Do we notice that work is missing? Okay. What is often done in a proof is that work is done off to the side somewhere. Okay. That work is done off to the side somewhere. Okay. So like maybe, for example, I would have it over here and I'd say, okay, well, here's my work. 4x minus 1 equals 27. I'm going to add 1. I'm going to add 1. 4x equals 28. I'm going to divide by 4. X equals 7. And then I'm going to go back to my proof and I'm going to fill in these 3 parts using what I started with, what I got after I did a step, and what I got after I did a step. Because is this, on the left-hand side, a lot cleaner than what we see on this slide?
It's less confusing.
Yeah, it's less confusing, okay? It's a lot cleaner. Okay? So our proof, we're going to leave it organized. It's not saying we can't do any scratch work to figure out our equation, because a lot of us will benefit from doing this work somewhere, right? A lot of us will benefit from doing that work somewhere. So it's going to benefit us to do it off to the side and leave this proof nice and organized, okay? Questions on that?
So is this like review?
Kind of, but we're learning the proof with it. So we're doing a review of algebra equations. So we're learning a new method of solving things, a new method of proving things, a new method of thinking and arguing. But we're doing it with something we're familiar with, so that way you guys can learn that new method easier. And then next class, we're actually going to start with doing this method with newer things to us, with more geometry stuff, okay? But I wanted to start you guys off with trying this out with things that are more familiar to us, like algebra. Does that make sense? Okay.
I like how you just have a sign up there exclaiming soccer. No, up there.
Yes, soccer.
And it should just be picture of-
Okay, on number 2, a over negative 6 plus 2 equals 5. And we're trying to prove that a equals negative 18. Well, the first thing we have to write is the first thing in our statement is what we're given. So we're given the equation a over negative 6 plus 2 equals 5. And the only way we know that's the case is because it's given to us. So that's our reasoning. Now from step 1 to step 2, my question is, what happened from step 1 to step 2?
Subtraction.
We subtracted. What did we subtract, guys? 2 from both sides. We subtracted 2 from the left, and we subtracted 2 from the 5 on the right. So what property tells us we can subtract the same thing from both sides of the equation?
Subprop.
So be careful. If I put sub, could that also be substitution?
Yes.
So I'm going to put sub t with the t there. That's going to help me clarify. Now, could this be substitution?
Put down the other one.
Okay. So this is the subtraction property of equality. Okay, so we have a little bit of ambiguity there if we just put the SUB, but if we put SUBT, we help ourselves out. Okay, questions on that? Okay, from step 2 to step 3, what's happening there?
Mult prop of equality.
We're multiplying both sides by negative 6. So it's the multiplication property of equality, or mult prop of equal, if you want to say it that way. So it's the multiplication property of equality. And we can abbreviate it as mult prop of equal. Saying, hey, it's okay that I multiply both sides of the equation by the same thing.
Is it?
Mm-hmm. Questions on that? Okay. I want you guys to try number 3. When you have it or have questions, I want you to raise your hand. Okay. So our first one is that we're given. Otherwise, we wouldn't know that equation true. Now, from step 1 to step 2, I saw a lot of people write multiplication property of equality. And it is true that we're multiplying. But are we multiplying both sides of the equation?
No.
No. We're not multiplying both sides of the equation by the same thing. So it's not the multiplication property of equality. Not division.
I
It
said
is- Distributive. It is the distributive property. We're distributing this negative 9 to the negative 2 to the 2x and the negative 3. So it is the distributive property. And that one you don't have to put of equality. You just put the distributive property. Okay? The property of equality. Whenever it's a property of equality, it means you're doing it to both sides of the equation. Questions on that step 2. From step 2 to 3, what are we doing?
Subtraction.
Yeah, we're doing subtraction, so it is the subtraction property of equality because we're subtracting 27 from both sides of the equation.
Oh, you're in water.
Okay? Yes. Number 4. How do I get to x equals negative 2? I do division, so I do the division property of equality.
The doggos in Africa need water.
Okay. Kenny will drop it for now, okay? Okay. So that is the division property of equality. Any questions on this proof? Proof number 3. Okay. I want you guys to try proof number 4. So for step 1, we're given the equation. So we're going to write that we're given. Are we noticing a pattern that the first thing is always what we're given and the first reason is always that it's given? Okay. Step 2. How do we go from step 1 to step 2 here? Well, 6x is no longer here and this turned into 2x. So what did we do? We subtracted 6x, so now we have subtraction property of equality, okay? Good luck, Kenny.
Alright, let's go. Let's go. Whatever.
Don't follow on the channel.
Okay? From 2 to 3, what did we do and what is the property? Seth?
From one to two. You mean?
From 2 to 3, we already did from 1 to 2.
Oh, we did. Addition property of equality.
Yeah, we use the addition property of equality to add 17 to both sides of the equation. From 3 to 4, what did we do, Ray?
Division property of equality.
Nailed it. The division property of equality to divide both sides by 2. Now here, this is kind of a little tricky because we had 12 equals x, but we're trying to prove x equals 12. Now, when you're given the amount of space for this, I'm going to ask that you finish this one off. But a lot of times, if you have 12 equals x or x equals 12, I'm going to be okay with you leaving that as is. But here, since it's already laid out for us, I'll have us finish it off. Okay? So once again, when it's already filled out for us like this, we'll finish it off. What property tells us we can just flip them around? It's the same thing. Okay, Christian?
Property of the equation.
Very good. The symmetric property. And I'm actually just okay calling it the symmetric property. Okay? Yep, sim prop. Okay? I'm actually okay just calling it the sim prop, the symmetric property, okay? Saying that, hey, we can flip things around, okay? Questions on that? Okay. How are you guys feeling on these? Give me a thumbs up if you're feeling good about it, and thumbs down if you're not. I want everyone to vote. Thumbs up if you're feeling good about it, thumbs down if you're not. I want everyone to vote. Okay, thank you. Continuing on. Let's look at number 5 here. Number 5, we have something slightly different. Step 1 is our given, and our reasoning is that it's given to us. What happens for step 1 and step 2? Yeah, distributive property. Now we're just doing it to both sides of the equation, right? Okay, so it is a distributive property. But we actually don't have to write of equality. It's a great idea, though, Seth. I love that. Love that. Because you're saying, we're doing it to both sides, so we should put equality. But we're not necessarily doing the same thing to both sides. Like, we're not multiplying the same thing on both sides. On one side, we're distributing a -7. One side, we're distributing a 6. Okay? Kenny Mask. And you. From 2 to 3, what happened? Okay? Not substitution. Ray, what are you thinking?
Subtraction.
Okay? Why are you saying subtraction? I hear subtraction, I hear addition. What are we thinking?
Because we had -7x and then we had 4x.
Mm-hmm.
So they just combined.
They combine.
That's addition.
Okay? So it kind of looks like addition, kind of looks like subtraction. Wait, what do we call it? Well, is it a property of equality? No, why not? Because it doesn't happen to both sides. So here's what I'm going to call it, okay? Combine like terms. Did we combine like terms? Yeah. So when we say combine like terms, we're just saying we're doing the like terms on one side of the equation, okay? We're not moving anything across the equation. We're doing them on one side of the equation, okay? And you could combine like terms on the left side and combine like terms on the right side in the same step, okay? Now, another way you could say it is that you simplify. You simplified your terms, okay? You could say either. So I want you to write down either right now. I want you to write down both of them because you really could choose either. And sometimes you'll see both. You'll see simplify in the word bank because on some of these we'll have word banks. So I want you to know that they're the same thing, okay? Now the rest of these we've seen before. What happens from step 3 to step 4? Okay, Seth? The subtraction property of equality. Now, is this maybe the math move a lot of us would have made here if we were solving this equation? Would a lot of us, would we have subtracted 12x here, or would we have probably added 3x? Probably add 3x. But does that make this math move not okay? No, it's still perfectly valid. So even if it's different than what you would do, you have to say, okay, just like when you're talking with somebody, it's different than what I would do or what I would think, but your reasoning makes sense. Oh, okay, you accept it.
My opinion is the only opinion.
Okay, probably not true. From number 4 to number 5, what do we do?
Addition.
The addition property of equality. And then from 5 to 6, the division property of equality. You guys are nailing these. Seriously, you guys are doing super well with them. Proud of you. Okay? Now notice, after you guys get to the end, you guys stop when we get to where we're trying to prove, right? You don't get to where we're trying to prove and then keep going, do you? What happens when you're talking with somebody and you're having a discussion and they get to where they're trying to prove and then they keep going? How do you feel about it?
Anger. Like they're shoving it down my throat.
You feel like they're shoving it down your throat. You're getting angry. You're feeling what?
Awkward.
You're feeling awkward. Okay, you might be getting annoyed. Okay, we're not going to do that. We're going to get to where we're trying to prove and we're going to stop. Okay, we're not going to be those people. Does that make sense? Okay, everybody stand up. Here, what do us hear about this proof?
There's
We have to do math too.
We have to do the math too. We have to do the statements too. Okay, now wait. What's going to be my very first statement? The equation that's given to us. So what am I going to write in there? Go ahead. Tell me, Quentin.
3x plus 1 equals negative 14.
Yeah, 3x plus 1 equals negative 14. And what's my reasoning for that? It's given to us. Now, are those basically two just freebies?
Yes, sir.
Hint, hint. Those two are always freebies. Wait, what's another thing that might be a freebie? Seth,
The last one.
the last statement is going to be what?
X equals negative 5.
The last one is always going to be x equals negative 5. Now, let me give you guys a tip here. On this one, we're actually only going to use 3 of them. So the last one is x equals negative 5. So do we already have this one halfway done? Okay, so on a test or quiz, if you have one like this, should you be able to get at least half the points for free?
Yeah.
Even if you don't know anything else other than the given statement goes here, the reason's given, and my last statement is what I'm trying to prove. You can already get 3 out of the points. 3 of the points here. Pretty nice. You don't have to know anything else, and you already get half the points.
3 out of the points.
Okay, 3 out of the points. Okay? Now, what would I do from step 1 to step 2 here? What are you thinking, Ray?
Well, I have a question.
Oh, what's your question, my dude?
So, like, if you had a problem like that, you could plug in 5,
Okay, could you plug in negative 5?
and then put, like, 15 plus 1 equals...
That wouldn't help us prove it. Unless we were to... That wouldn't help us to prove it in multiple steps. That would just be checking that it is true at the end. So you could, but you'd have to... We'd be going entirely different steps, and it would actually take more steps. You could do that, but in this one we wouldn't. Does that make sense? Like you could, but it would take longer. Kenny,
We're going to do the division property.
I'm going to disagree with you. Let's write out this equation off to the side. 3x plus 1 equals negative 14. You would subtract 1 to start. 3x equals negative 15. So I'm going to write my 3x equals negative 15 here. I'm going to write the fact that we did the subtraction property of equality to say we can subtract both sides by the same thing. Welcome, Tyler. Happy to have you here, buddy. Okay?
We missed you.
Well, I did. Okay, we are on the... flip the page. We're right here. Thanks. You're welcome. Okay. Now, from step 2 to step 3, what tells me I can get there? The division property of equality says I can divide both sides by 3 and get x equals negative 5. So can you guys see how it might be helpful for us to write our work off to the side somewhere else? Okay? That can even help us know what to do, not only know what to write here, but know what the step was. Okay, if we just think through, well, how would I solve this? Okay, questions on that one? Okay, let's go on to number 2. This one will use all 4 of the boxes. Who can tell me one of my freebies? Okay, Kevin.
2 x minus 9 equals negative 10.
Yeah. It's going to go on my first statement. Who can tell me another freebie? Seth.
X equals 4.
Where's that go? Statement 4. Okay, Kenny, what's another freebie?
There is one.
Oh, there isn't?
Yeah, on reasons.
Reason.
Given.
The first reason is given.
It is given to us.
It's given to the given is literally given. Okay. 2 times the quantity of x minus 9 equals negative 10. What would be the first step we do here? Distribute. So I'll distribute 2x minus 18 equals negative 10. Now I know what to write in statement 2. And what's my reasoning for that? Why can I do that? Because the distributive property tells me I can. Distributive property tells me I can distribute.
Wow, it's crazy how it works.
Yeah, pretty neat. You can tell because of the way it is. Now what would I do in my equation? 2x minus 18 equals negative 10. we'd add 18 to both sides. 2x equals 8. Nailed it, Kevin. And that is the addition property of equality, saying I can add the same thing to both sides of the equation, and it's perfectly good. Now I get x equals 4. How do I get there? Chase? The division. So we're using the division property of equality. Questions on this? So we're doing a lot of the same algebra we've done for over a year now? Yeah, we are. We're just saying here are the actual justifications behind it.
Just because I can.
Here's the properties that we were using the whole time. We're just saying what they are now. Okay?
Can we just call it really?
Okay? We are going to skip 3 and 4.
No. I mean,
You want to do them?
no, I want to do homework.
Oh, okay. We'll do 3 and 4 for Ken. Just kidding. Okay.
I thought it said Coke.
We'll actually skip number 5 as well. Let's go to 6.
Where are we going?
To 6.
Obviously.
What do you guys notice I did here on number 6?
Start it.
I put a star on which one? 4. Okay. Here's why. I put in my first statement. 5n minus 42 equals 12n. That's a given, right? What's my first reason? Given. That's a freebie. What's my other freebie? N equals negative 6. Where's that going? Bottom left. Last statement. Okay, I put a star next to it. We'll talk about that in a moment. How would I solve? How would I start on number 1 here if I were to do my work up the side?
Subtract 5n.
Subtract 5n. Let's get all the n's together. Negative 42 equals 7n. So I'm going to write that in the box. And what tells me it's okay that I subtracted 5n from both sides?
Subtraction property of equality.
Yeah, the subtraction property of equality does. So now what would I do? Divide by 7. So negative 6 equals n. What tells me it was okay that I did that?
Division property.
Yeah, the division property of equality tells me I can divide both sides by 7. Now, what happens from step 3 to step 4? Symmetric property. We flipped it, right? Now, personally, I'd be okay with us solving this in 3 steps and ending it here. I legit would. Because it's not already filled out for us, I'd actually be okay with that. But be careful, if you're going to put what we're proving in the last one, you can't put it in step 3. You cannot put step 4 and step 3 and call it good, because then you'd be doing 2 steps at once. You'd be dividing both sides by 7 and flipping it. We can't do both at once. So if you're going to write n equals negative 6, it has to go in the bottom one, and you have to say that it's a symmetric property. But if you want, you could stop at statement 3 here, and I'd be okay with that. Because I would consider n negative 6 equals n to be the same thing as n equals negative 6. Does that make sense?
Is that a Y?
Yes, SYM.
It's a W.
I guess assuming you're talking about the letter between the S and the M, then yes, it's a Y. If you're talking about any other letter, then no. But I assume that's the letter you're talking about. Hey, what'd your brother think about my spaceship comment?
Spaceship.
His brother's truck sounds like a spaceship when it's driving. It legit does.
Like, does it whistle?
No.
No, it sounds like a spaceship. Like, just imagine what a spaceship would sound like when it's taking off. It's that.
Like thruster noises?
Yes.
Yeah.
Like,
You should hear it when it's idling.
Yeah, but it sounds like even more so when it's starting to move.
is it
I know
straight pipe?
you read them sounds.
Okay,
Is it no pipe?
give me a thumbs up if you're feeling good. Thumbs down if you're not. Everybody vote. Thumbs up if you're feeling good. Thumbs down if you're not. Everybody vote. Everybody vote. Everybody vote. Everybody vote.
Vote.
Okay, perfect.
So I'm gonna go.
We're gonna skip number 7 for now.
Please vote.
We're gonna skip number 8 for now.
Are we ever gonna go back?
Okay.
Sounds like a bad game. Yeah.
Okay. Name that property. Match the statements with a property of equality. Properties will be used more than once. If k equals 3, then 3 equals k. Which of these properties does that use? H, symmetric property. Here's what I want you to do. Seth and Lauren, you'll do number 2. Quentin and Ray, you'll do number 3. Ryan and Landon, you'll do number 4. Okay? Tyler and Christian, you'll do number 5. Kenny, you're doing number 6 on your own. Kevin and Elizabeth, you're doing number 7. Chase and Bailey, you're doing number 8.
Wait, so I'm the only one alone? Let's go.
Yep.
I got this. Oh, I got this. I'm already
Wait,
going.
what are we doing?
I don't know.
What number did you tell us?
Can I help them?
What number did I tell you?
6.
You're 5.
Can I
I
help
thought
them?
you said I'm
Sure.
fired.
No.
I'm just confused on everything.
Yes, because if you missed the first part, go back and watch the video later and it'll make more sense, I guarantee it.
Well,
Okay?
that's
Kenny.
not if I'm passed out sleeping or class.
Oh, not yet.
I understand it. I understand.
Well, I just had 2 cc's of numbness shot in my shoulder that are wearing.
Seth and Lauren, what letter did you guys have? If 2x equals 14, then x equals 7. What? Doggo. D as in doggo, the division property of equality, okay? Number 3, Quentin and Ray. What did you guys have for 4 equals 4? G, the reflexive property. That is a real G, okay? Number 5, that was you, Kenny? Or no, that was you two up here front. Excuse me. Christian and Tyler. If negative 5x minus 1 equals negative 11, then negative 5x equals negative 10. What tells us we can do that?
You just we had 5.
Okay, did I say... Okay, 4. Who had 4? You two back there, excuse me. 4. What is that? A, it is the addition property of equality. We add 1 to both sides of the equation. Okay, number 5. Now Christian and Tyler. If 10a equals 2b plus and 2b equals c, then 10a equals c. That is letter I, the transitive property. Cut out the middleman.
E.
Okay? Negative 7 times the quantity of x minus 4 is equal to negative 7x plus 28. That is E, the distributive property. Very good, Kenny. Number 7. 6y equals 24. Then 6y minus 3 equals 24 minus 3. Which one is that?
We don't know.
That's a tricky one, isn't it?
Yeah.
Okay? So what changed between this first part to the second part?
You added 3 to both sides.
We didn't add it, but we
I mean,
subtracted 3. So what tells us we can subtract 3 from both sides?
B.
B, the subtractive property of equality. Now, is it very helpful on this one?
No.
No. But can you still do it?
Yeah.
Yes. It's tricky because it's not helpful. It's not a math move we would actually do, but it is actually mathematically okay because of that property of equality. Does that make more sense? Number 8, which is unfortunately not up on the slide, if 10x plus y equals, let's say it again, if 10x plus w equals 41 and w equals 1, then 10x plus 1 equals 41. Chase and Bailey, what do you guys have?
I put F.
F, substitution. Bailey, what do you have?
I don't know.
Okay, I would agree with substitution. We're saying w equals 1, so we replace w with 1 in the equation, but everything else stayed the same.
Can we get an F instead?
Continuing on. Okay, Seth and Lauren, number 9. Quentin and Ray, number 10. Ryan and Landon, number 11. Christian and Tyler, number 12. Kenny, number 13 again. Okay, Kevin and Elizabeth, number 14. And Chase and Bailey, number 15. Seth and Lauren, what do you guys have for number 9? C, that is the multiplication property of equality, so that I can multiply 2 on both sides and get the resulting equation. Number 10, Quentin and Ray, what do you guys have? That is I, the transitive property, okay? 3x equals 2y, 2y equals z, now 3x equals z. Number 11, Ryan and Landon. If 7m equals 35, and then 7m plus 4 equals 35 plus 4. What's that? It is A, the addition property of equality. Once again, is adding 4 very helpful there? No, but we can do it to both sides of the equation because of that property. Okay, number 12, Tyler and Christian. If negative 2x equals 18, then 18 equals negative 2x. H, that is a symmetric property. Did you guys have the same one last time? No, okay. 13, given 3x squared plus 1, if x equals 5, then 3 times 5 squared plus 1. Okay, Kenny, what's that?
It's substitution property.
It is substitution property. It's F. Very good. We can substitute 5 in for x. Okay, Kevin and Elizabeth, 14. If m equals negative 2, then 8m equals negative 16. I'm actually going to disagree. You're going from then to if. We're going if to then. So which way would you go from this to this? The left to the right. I think you went the opposite direction. So what's the opposite of division? Multiplication. That's a multiplication property of equality, letter C. Once again, is that very helpful? No, but we can do it. Okay, Chase and Bailey. 10y equals 10y. G as in reflexive property. Anything equals itself. Last but not least, I'll do this one. 5x plus 8x equals x times the quantity of x plus 5, or x times the quantity of 5 plus 8. That would be our distributive property.
Let's go.
Where are we going?
Wait, how is that?
That one really should be flipped around, shouldn't it?
Couldn't it be, hold on.
Factoring.
Backwards.
Well, yeah.
Really, this one should be flipped around, shouldn't it?
Backwards.
Okay, backwards E. So we'll do.
Couldn't it also be reflexive?
Nope, because reflexive means you have the same exact thing on both sides. Great question.
Oh, okay.
Yep. Okay. Questions on any of these, guys? Alrighty, time for the homework.